Hi there, this is Math 6, Unit 4, Lesson 11, using an algorithm to divide fractions. Okay, so here we go. So we've kind of worked through lessons about 6 through 10 here, working on the way to visually see how fractions work. And so today we're start talking about an algorithm. It's almost like saying a little bit easier way of doing it without a lot of pictures and graphics. So let's take a look at this today. So here we go. In our last lesson, we learned a rule that taught us that if we take a fraction of some sort or a number and we divide it by a fraction, well, let's just say, let's just take a number 3. Take 3 and we divide it by a over b. That is equivalent to taking 3 and multiplying it by b over a. Right? We sometimes refer to that as multiply by the reciprocal. So here we have some multiplying of fractions today in the first activity. And we can see here that if I was to actually multiply this out, I could do a 27, and let's do it this way. We could really have 2 times 27, and that's all over the 3, right? So if you set it up like that and just take a look at it, I know that the 3 and the 27 are related because 3 times 9 is 27. So for me, I would reduce this to 9, first of all, over 1. And that leaves me with 2 times 9, which is going to be equal to 18. Okay? So you can multiply it out. You could even say 54 over 3, right? I could have said multiply that and had 54 over 3 for that one. And then figured out how many 3's are in 54, and I would still end up at 18. Another thing you can think about is this is like 27 over 1. And again, I can then reduce right here on this diagonal, which becomes a 9 and a 1, which is still 9 times 1, which is 18. Let's take a look at number 2. On number 2, I can see on the diagonal right here, these are going to be in common. The reason I look at the diagonal is, again, I could reorder this. This becomes 1 times 2 over 2 times 3. Right? If I multiply it out, 1 times 2 is 2, and 2 times 3 is 6. And so what I'm doing is I'm going to reduce to 6, right? That's what's going to happen. But if I recognize that this is also a way of saying it's 1 times 2 over, and let's just do this because multiplication, the order doesn't matter when you multiply. Let's do 3 times 2, right? So that's okay. So we can do 3 times 2, and 2 over 2 is equal to what? 2 over 2 is equal to 1. So that goes away. So what I'm left with then is simply 1/3. Or if I reduce it here, that 2 and that 2 reduce to be 1 over 1, which is the same as what I see here. I'm left with 1/3. And what is 2/6 reduce? It becomes 1/3. I know I'm doing a lot of stuff in there just to show different ways of looking at it, but that's because later on I'm going to do a little faster, and I want you to see how I'm making some quick reductions, okay? So here on this one, number 3, I have a 9 and a 3 working on the diagonal side. 3 goes into 9 3 times. So I know I have 1 3 here in that group, and I have 3 3's in that group. So now I can multiply across, and 2 times 1 is 2, and 3 times 5 is 15. And 2 and 15 don't have anything else in common, so we just leave it just like that. When I look here, I have a 100 and a 200. Well, 100 goes into 200 2 times. So there's 1 100 here and 2 100s there, so I can reduce that. I can also reduce on this diagonal as well, because I have 1 9 here and I have 3 9's in that group. So now I multiply across. 3 times 2 is 6, and then 1 times 1 is 1, so I just leave the answer as 6. For this one, I'm going to want to rewrite this one. Instead of mixing them, I'll write it as an improper fraction. So 4 times 1 is 4. Plus 3 is 7, so I have 7/4 times 5 7's. Now again, when I have the same number working in the diagonal, there's one group of 7 here and 1 7 there, so those reduce down to 1 over 1. Then we're left with 1 times 5 is 5, and 4 times 1 is 4. I could leave it like that, or I could say that this is going to be how many 4's are in 5? There's one group of 4 inside of that, and I have 1 left over. So 1 1/4. Okay, so now we're going to look at activity 2, which is something you're going to use. You're going to do some work, and your partner's going to do some work, and then we'll compare some notes together, all right? So it says work with a partner. One person should work on the questions labeled partner A, and the other should work on those labeled partner B. Partner A, here we go. Let's look at what you had to work with first of all. All right, so first of all, if you're looking where we are now, you can either do them on your own. If your teacher has you trade and take a look, then push pause and do that, and then come back together. So partner A, find the value of each expression and answer the question by completing the diagram that has been started for you and show your reasoning. Okay, so we have 3/4 divided by 1/8. How many 1/8 are inside of 3/4 is our question, right? How many 1/8 are inside of there? Well, an 1/8 is essentially half of a 1/4, okay? Because this is a whole, and these are all fourths. Would you agree with that? This is a 1/4, 2/4, 3/4, 4/4. So if I divide each of these into half of those, now I have 8s. Why is it 8? It's because in total I have 1, 2, 3, 4, 5, 6, 7, 8. So those are my 8s there. So the question is how many 1/8s, which is this size right there, are inside of the 3/4. So here I have 1, I have 2, 3, 4, 5, and 6. And I'm going to stop there. Why? Because we're only looking at how much is inside of the 3/4. The 3/4 is right there. And so we can see that I have 6 of these 1/8 segments inside of there. So we're going to say 6. And that's how you can look at that. That's what's in there, right? So if we were to do the division part of this and double check that, 3/4 divided by 1/8, right? That becomes 3/4 times 8/1. And 8/1 can reduce. There's 1/4 here, and there are 2 4s there. So 3 times 2 is 6, and 1 times 1 is 1, and we have matching numbers there, so we're okay. Let's take a look at the next one. We have 9/10 divided by 3/5, right? So we know that we're looking for, in this segment right here, how many groups of 3/5 are in that segment. Well, 3/5, I need to think about this one here because this one's a little different. This is broken up into tenths, right? So a 1/5 is actually going to be this size. This size, this size. And the reason we say that is because if you look, how many kind of the purple reddish groups are there in the whole thing? We have 1, 2, 3, 4, 5. That's what's in the whole thing there. Now in terms of how many 3/5 are inside of that group, we can see right now that this is a 3/5 segment, right? So we know for sure we have 1. Like that's a given. We know we have at least 1 3/5 inside the whole thing. But then we also have that part right there. And that's the value that might be a little bit trickier to take a look at. And so, well, how much is that? Right? It's not 3/5. 3/5 would be 1, 2, 3 of those yellow blocks. I can make 1 yellow block and I have half of a block. So think of it this way. If this is going to be 3 of those yellow blocks there and I have 1 1/2 of that, what I really have is I have half of a 3/5, don't I? Why do I say half of a 3/5? Well, think of this. This is 1, 2, 3 little blocks, right? And how many are in this section? 1, 2, 3, 4, 5, 6. So I have 3 out of what I need to have, which is 6. Right, these are my extra. Remember before we did this, we would say, well, we'll make our extras like, I think we did them pink if I remember right. Right, these are the extra ones. So what do I do with those 3? Well, I know that I have 3 box checked, and I need to have 6 altogether. Well, 3/6 is the same as a half. So what I really have here, how many 3/5 are in there? There are 1 1/2 groups of 3/5 inside of that right there. Okay, so that's a lot of talk to show it there. Let's look back here at our division problem. If I do 9/10, and instead of dividing by 3/5, if I multiply by that reciprocal 5/3, now we can do what we did earlier on. We can reduce. How many 5s are between 5 and 10? There's 1 5 here, there's 2 5s there. If I reduce 3 and 9, there's 1 3 here, and there are 3 3s in 9. So we multiply that out. We have 3 times 1 is 3, 2 times 1 is 2, so we have 3 halves, which becomes 1 1/2. So we have shown that it's the same thing, and that's what you got. Okay. All right, let's take a look at what partner B was working on. Partner B. So for partner B, it says if you wanted to divide 4 by 2/5, you can multiply by 4, or so you can multiply 4 by 5, then divide it by 2, or multiply by half. That's what Elena is telling us. Find the value of each expression using the strategy that Elena just described. All right, so let's take a look at this. She's saying if we take 4 divided by, divide 4 by 2/5. If we say 4 divided by 2/5, what she's saying is that step 1 is first to multiply 5 by 4. So step 1, we're going to go 4 times 5. That's our step 1. And then divide it by 2. So then whatever that is, then we take that answer and then we're going to divide it by whatever that number is. And that's going to give us our solution. Okay? So what we're doing is we're taking the number here, multiplying it by the denominator, that's what the 5 is, and then we divide it by the numerator, or multiply by a half. So let's take a look and see how this works here. So, find the value of each strategy using what she did there. Alright, so the first thing we're going to do is we're going to take 3/4 and we're going to multiply it by the denominator. So 3/4 times 8. Alright, or 8 over 1 if you want to think of it that way. This can reduce. 4 goes in there once, 4 goes in there twice. So now I have what? I have 6 so far. And now I need to multiply it or divide it by the numerator. The numerator is 1, so we're going to divide that by 1. And 6 divided by 1 is 6. Okay? Let's try the next one. We're going to do 9/10. And the first thing we're going to do is we're going to multiply it by the denominator. So multiply it by 5, or 5 over 1. If you want to put a 1 there, you can. I know I can reduce on the diagonal. This becomes a 1. That becomes a 2. So now I'm at 9 over 2, or 9/2. And now I need to, what do we say? Divide it by the numerator. So we're going to divide it by 3. Divide by 3. Or, right, this one's divided by 3. We could say divide by 3, but divide by 3 also means what? Or multiply by 1/3. So we could say that, or we could say 9 over 2 multiplied by 1/3. So we're taking the 3, and instead of doing 3 over 1, we're multiplying by the reciprocal. So then I can reduce 3 and 9. That becomes a 1. That becomes a 3. And I'm left with 3 over 2, which is 1.5. Alright, so that's what partner B was up to there. So, we're going to have a little discussion with your partner if you haven't done that already. Talk about what you're noticing there, what you're seeing, and then we complete the statement. To divide a number n by fraction ab, we can multiply n by b, that's the denominator, and then divide the product by a, the numerator. That's the idea. So let's select all the questions that represent the statement you completed. So let's see. We're taking n divided by a over b. We multiply by b, check, and divide by a, check. So that one works okay. Here we're saying n divided by a over b, n times a, that's going this way. That's not what we said. Here we're saying n times a over b. Well, it already is a over b, so what changed there? That's the same thing, except we changed the operation. That's not going to work. And here we're multiplying by, instead of a over b, we're multiplying by b over a. So that's the reciprocal, so that one is okay as well. Alright, now we're going to move into activity 3, which is really using the algorithm, as the lesson is talked about here, to figure this out. So we're going to calculate the quotient using your preferred strategy. So you can decide how you want to do this, okay, and solve these ones. These are basic computation problems dealing with dividing fractions. So I'll show you how I do it, and then if you have a different way, that's okay. So here we go. So for me, I like to take the first fraction, and instead of dividing by 4, I'm going to multiply by the reciprocal, so 1/4. I'm going to look for things I can reduce. I have 1 4 here, and I have 2 4s there. And I multiply straight across. 2 times 1 is 2, and 9 times 1 is 9, and so I have 2 9s. Here, again, I like to go 3 4s, and I like to multiply by the reciprocal. Alright, I can see something in common here between a 2 and a 4. I have 1 2 here and 2 2s there. Multiply straight across. 3 times 1 is 3, and 2 times 1 is 2. So I have 3 halves, or 1 1/2. If I want to make that a mixed number. Here I need to rewrite this one. 3 times 3 is 9, plus 1 is 10. So we have 10 thirds. Let's multiply by the reciprocal of 2 over 9, which becomes 9 over 2. We can see here that we have 3's and 9's in common. How many 3's are in 3? 1. How many 3's are in 9? 3. Here I have 2 and 10 are connected because they go with each other. They're both even too. So I have 1 2 here. How many 2's are in 10? There are 5 2's there. So we're going to multiply straight across. 5 times 3 is 15, and 1 times 1 is 1, so we can just leave it as 15. Alright, the next one. We keep the 9 over 2, multiply by the reciprocal of 3/8, which is 8 over 3. And look here, can I reduce 8 over 2? Sure. I have 1 2 here, and I have 4 2's there. I have a 3 and 9. Are they related? Sure they are. I have 1 3 here, and 3 3's there. Multiply across. 3 times 4 is 12, and 1 times 1 is 1, so I just leave it as 12. And finally, let's fix this mixed number to an improper. 5 times 6 is 30, plus 2 is 32, and keep the denominator the same. We're going to multiply by the reciprocal. What is 3? 3 is 3 over 1. So the reciprocal would be 1 over 3. Alright, 5 and 1, anything in common there? Nope. How about 3 and 32? You might think there is, but there's not. I mean, think about your 3's. You know 3 times 10 is 30, and 3 times 11 is 33. So 32 is not going to be connected with a 3 at all, so it's just going to be stuck like that. So 32 times 1 is 32, and 5 times 3 is 15. We could leave it like that, or we could notice that 15 times 2 is 30, which tells me there are 2 groups of 15 inside of there. And how much is left? 32 minus 30 is 2 left over, and the denominator stays the same, so 2 and 2/15. Alrighty, so a lot of computation there, and that's just using the algorithm multiplying by the reciprocal. Okay, so after biking 5.5 miles, so she's gone 5.5 miles, Jada has traveled 2/5 of the length of her trip. Alright, that's the whole trip. The whole trip. How long in miles is the entire length of her trip? The whole trip. Write an equation, represent the situation, and find the answer using preferred strategy. So what we're saying here is this, right? Think about this. This is where it gets a little like tricky in your head a little bit. She's gone 2/3 of the whole trip, right? So we know this. She's gone 2/3 of the whole trip, and that means she has gone, and that is 5.5 miles. So what we know is that 2/3 of the whole trip is 5.5 miles. This is what this is telling us right here. Read it again. After biking 5.5 miles, that's how far she's gone, Jada has traveled 2/3 of the length of her trip. So 2/3 of the trip is 5.5 miles. So now we can turn this into a multiplication problem. This is 2/3. Generally, when we say of something, that means multiply. 2/3 of the trip, we don't know what the trip is usually means equals. So 2/3 of the trip is 5.5. As a multiplication problem, it looks like this. Okay, can we turn that into a division problem? Sure. If we want to get the 2/3 over there, we're going to divide 5.5 divided by 2/3 is going to equal the trip. Okay, so to get this over there, because it's connected by multiplication, I separate by division, so I divide it by 2/3. So now let's turn this into a improper. 2 times 5 is 10, plus 1 is 11 over 2. This is divided by 2/3. We will then multiply by the reciprocal, right? And then we see, can we reduce a 2 and a 3? Nope. Reduce a 2 and 11? Nope. So I multiply it out. We have 33 over 4. And I know that 4 times 8 is 32. So 4 goes into 33 at least 8 times. 33 minus 32 leaves me 1 left over. So I end up with 8 and 1/4 is going to be my solution for how long the whole trip is going to be. Okay, so that's really it for today's lesson. Let's take a look at your summary. Our summary tells us the division a divided by 3/4 is equal to question mark is equivalent to 3/4 times a question mark equals a. So we can think of it as meaning 3/4 of what number is a? 3/4 of what number? Of what number? That's this part there. Of what number is a? To represent in a diagram as shown. Here we go. The length of the entire diagram represents the unknown number. So we know we're looking for the whole amount, and this is 3/4 of a. So if 3/4 of a number is a, then to find the number, we can first divide a by 3 to find 1/4 of the number. Then we multiply the result by 4 to find the number. So the steps can be written as a divided by 3 times 4. Right? This is a divided by 3 times 4. Dividing by 3 is the same as multiplying by 1/3. So we could say a times 1/3 times 4. In other words, a divided by 3 times 4 equals a times 1/3 times 4, and a times 1/3 times 4 is equal to a times 4/3. So we could do all this, sounds like a Dr. Seuss book right there. Or we can simply say that a divided by 3/4 is the same idea as saying a times 4/3. In general, dividing a number by a fraction CD is the same as multiplying the number by DC, or what we call the reciprocal of the fraction. And that's our big takeaway from the day. That's the algorithm that we're using to solve these fraction problems. All right, so we're going to pause there, do your homework. We'll come back together in just a moment. Okay, here's our homework for Unit 4, Lesson 11. This is 6th grade math, using an algorithm to divide fractions. Select all the statements that show the correct reasoning for finding 14/15 divided by 7/5. Okay, 14/15, multiply 14/15 by 5, then by 1/7. Well, multiplying by 5 is multiplying by the denominator, and then by 1/7 is multiplying by the reciprocal of 7. That's going to be a true statement. So yes, that's true. Dividing 14/15 by 5, then multiplying it by 1/7. That's going to be the wrong way, right? That's doing 14/5 divided by 5. Well, we're already dividing by 1/5. That's flipping it, but doing the signs the wrong way. This part's okay, but the dividing by 5, that part right there is wrong. It's not going to work. Okay, multiplying 14/5 by 7, then that's just doing this. That's just forgetting the sign altogether. That's not going to work. And then multiplying 14/15 by 5, so multiplying this by that, then dividing by 7, that's the same, because dividing by 7 is the same as multiplying by 1/7, so that's true. All right, number 2. Claire said that 4/3 divided by 5/2 is 10/3. She reasoned that 4/3 times 5, so 4/3 times 5 equals 20/3, and 20/3 divided by 2 equals 10/3. Explain why Claire's answer and reasoning are incorrect, and then find the correct thing. Okay, let's take a look here. First of all, the first thing that she did is she multiplied by 5, right? That's our first error here. Why is that an error? Because we take this number and we should be multiplying it by the denominator. So the first error is she multiplied by 5. That should be multiply by the denominator, which is here, the 2. The second mistake then is then when she divides by 2, that should be, divide by 2 should be divide by 5. All right, let's show this here. It should be 4/3 times 2. All right, that's the bottom one there, which doesn't reduce. That becomes 8/3. And then we multiply by the reciprocal, or we divide by the numerator, which is 5. And so you end up with 8/15. That's what should have happened. But she did things backwards there. So we got to go down and then go back up. Instead, she went up and then down. Okay, let's find the value of this one. Okay, we have 15/4. We're going to multiply by the reciprocal, which is 8/5. Let's reduce 8 and 4. I know I have 1 4 there, and I have 2 4s there. I have 5 and 15. I have 1 5 here, and 3 5s in there. 3 times 2 is 6, and 1 times 1 is 1. So we leave it just like that, and that's all you have to do. Are there other ways of doing it? Sure there are. You could have done 15 times 4 times the denominator, which is 8. And when you do that, we reduce, and we have 2/1, which becomes 30. And then we're going to multiply by, or we can say, first for kicks, let's divide by the numerator, which is divide by 5. And 30 divided by 5 is 6, and we're still in the same spot. Okay. Next one, here we go. It says Kieran has 2/3 pounds of flour. When she divides the flour into equal-sized bag, he fills, I always say she. So this is a guy, I always forget. He fills 4/8 bags. So he divides them in equal bags and fills 4 1/8 bags. How many pounds fit in each bag? Okay. So it's 2 3/4 pounds of flour. He divides it in equal bags and fills 4 1/8 bag. So how many pounds fit inside of each bag? So what we have is we have 2 3/4, and we're going to divide that into 4 1/8 bags to figure out what we have. There's the division problem. As a multiplication, I could say I have 4 1/8 times some amount is going to give me 2 3/4 pounds of flour, right? So I know that I have 4 1/8 bags times some amount is going to be filled up with that amount there. So to solve this here, let's use the division one. Okay, we have 2 3/4 divided by 4 1/8. So 4 times 2 is 8, plus 3 is 11. Keep the denominator the same. And we divide it by 8 times 4 is 32, plus 1 is 33/8. Now let's rewrite this here as 11/4 times the reciprocal, which is 8/33. How many 4s are in 4 and 8? There's 1 4 here, and there are 2 4s there. How many 11s are in 11 and 33? There's 1 11 there and 3 11s there. So 1 times 2 is 2, 1 times 3 is 3, so we have 2/3. And so if you think about this, what we're saying is that there are 2/3 pounds in each of the bags, and that's how you end up using that flour up there. All right, next one, number 5. Divide 4 1/2 by the following unit fractions. All right, so we're dividing 4 1/2 by each of those. 4 1/2 is what we're working with here. Let's write that as an improper. 4 times 2 is 8, plus 1 is 9, so this is 9/2. So we're going to do 9/2 divided by 1/8. All right, so this is really, if we write this out as, with our algorithm, it's 9/2 times 8/1. I can reduce this. This is a 1, and this is a 4, and 9 times 4 is 36. Here we'll do 9/2 divided by 1/4, which becomes 9/2 times 4/1. We reduce this here. This becomes a 2 and a 1, and so we have 18 there. And then the last one over here, we have 9/2 divided by 1/6 becomes 9/2 times 6/1. This reduces to 1 and 3, and 9 times 3 is 27. All right, here we go, number 6. 6 and 7. I got some review questions here as well. So after charging For 1/3 of an hour, a phone is at 2/5 of full power. How long would it take the phone to charge completely? Decide which equation can represent the situation. So we're not even solving it here, we just want to figure out which one's going to match here. Alright, so let's look what we have here. We have right there a statement that says that 2/5 of full power is how much? Well, it's at 1/3 charge. So 2/3 of full power is at 1/3. That's what we have, which is really 2/5 times something, we don't know full power, full charge, is equal to 1/3. Well, that one right there is going to match this guy right there. That's easy enough. So which one of the division problems, C or B, is going to match that? Well, to move the 2/5 over here, we're going to divide. So that becomes 1/3 divided by 2/5 is equal to the question mark. So which one does that match up with? Oops, ran out of space there, sorry about that. Well, that's going to be right here at B. Let's use that same strategy here for this next problem. I'm going to zoom out so we can get on one page for you. It says that Elena and Noah are each filling a bucket with water. Noah's bucket is 2/5 full and the water weighs 2.5 pounds. How much does Elena's bucket weigh if her bucket is full and her bucket is identical to Noah's? Alright, so let's think about this. This again is 2/5 of full is at 2.5 pounds, is what we're saying. Right? 2/5 of a full bucket is 2.5 pounds. So as a multiplication problem, we could say 2/5 times something we don't know, because we don't know what full is equal to 2.5. As a division problem, we would say this is 2.5 divided by 2/5 equals something I don't know, right? Because to move this over to there, we're going to divide. Okay? So that's what we have so far. That's how we get our multiplication and our division. 2/5 of a full bucket is 2.5. That's what they tell us here in the problem. So now I could do the math. 2 times 2 is 4, plus 1 is 5. So we have 5 over 2 divided by 2/5. Well, that becomes 5 over 2 times the reciprocal, which is 5 over 2. And to multiply that out, I can't reduce diagonally. You don't reduce horizontally ever. Always look at the diagonal. Nothing there, or vertical. Right? Nothing there. So we have 25 over 4. 4 goes into 25. Well, 4 times 6 is 24. So we know it goes in there 6 times. 25 minus 24 leaves me 1 left over. And the denominator stays the same, so 6 1/4. Alright? And that's what's going on with that one right there. So as a diagram, what can we show here? Okay. We know that we're looking at 2/5. So we take the whole bucket and we break it into fifths. Right? That's the whole bucket. We know that with 2/5 of this filled in, 2/5 there, we're at 2.5. So we figure out how much goes in there. Well, think about 2.5. What is half of 2.5? Everybody gets 1, right? Half of 2 is 1. And what's half of a half? Is a fourth. So everybody gets 1 1/4 each time. So really we're saying is if I take 1 1/4 times 5, then I'm going to find out my same number. Well, what is 1 1/4 times 5? 4 times 1 is 4, plus 1 is 5. So we have 5/4 times 5, which equals 25 over 4. Does that look familiar? Sure does. It's right there. So we did a good job there. Alright, that's it for today. We will see you next time.